I hope that you have read this question. So let's concentrate on what this question wants to tell. So here it is being given that we have to take out the time. How soon it does mean that we have to find the time, and to find the time we just need acceleration. And the most common form of finding the accelerations in such constrained motions is by using this simple law. Although this law is not the same as this, but it is very much widely applicable, and I can just derive it in a few seconds. Since this is a constrained motion and it is a self-sustained motion, hence the net work done will be 0. Hence, and I know what is the work done. It is equal to force into displacement dot product, and that is equal to for this case it is equal to T dot H, and I'm just taking the vector form, and if I just differentiate it will be T dot V, and if I double differentiate it can be made to T dot A. So I'll just retain this form, and the net summation of this is going to be 0. So yeah, but how can I find the acceleration of these blocks? Right now this sphere is undergoing a tension of T, and the same tension is being carried out by the same wire, but as it reaches this pulley, this tension gets divided, or I must say that these two segments contribute total tension T, so this must be contributed T upon 2. So if this contribute T upon 2 in the upward direction, and this T also in the upward direction, and I just assume that the acceleration of both of them is in the upward direction, so T dot A1 plus T upon 2 dot A2 is equal to 0. So I just get this relation minus 2A is equal to A2. Now I get to know that if the acceleration of the sphere is upwards, the acceleration of this will be downwards. So what will be the next net acceleration? It is equal to A relative, and A relative is equal to A1 minus A2, that is equal to 3A1. Okay, now let's apply the real form of this law, or the Newton's second law, and investigate what the actual value of acceleration is. Now in the first case, if I take T minus 1.8 mg is equal to 1.8 ma, this relation will be wrong. Why? Because we conclude that since the acceleration, what I'm saying, this relation will be correct. But let's say if I want to do the opposite thing, I just think that the sphere might be coming downwards, so my relation will come out to be 1.8 mg minus T is equal to 1.8 ma, and if it is coming downwards and it is going upwards, then its acceleration will be given by T upon 2 minus mg is equal to minus ma2, because I had taken a2 initially to be upwards, but now I'm thinking it is downwards. So by solving both of the equations, I get the value of a1, that is the acceleration of the sphere, to be this much, minus g upon 27. So if this is minus g upon 27, we get mathematically our expression valid, that the acceleration of the sphere is upward and not downwards. Okay, and if it is not downward, it does mean that the sphere is moving up and the rod is moving down. So the net acceleration of the system, as I just derived earlier, is going to be a1 plus a2, or a1 minus a2, and this will be total of 3a1. So the net acceleration is 3a1, and by using the normal format or the normal equation, that is ut plus half gt square is equal to, or not gt square but at square is equal to s. For this case, s is given as h, which is 100 centimeter, and u is equal to 0, and a is equal to 3a1. So putting the value, we get time is equal to this much, and on further solving we get the time as to be somewhat this much, but particularly solving it comes out to be 1.4 seconds. By just manipulating some of the variables or some of the real values, we get 1.4 seconds as the correct answer.